Okay guys, in this section 7-8, the topic here is, there's really two topics, but the first thing that we come to is the double angle formulas. And so as we take a look at the form of these double angle formulas, it's when you've got an angle in the form of 2u here. And I know we did have a section where we solved some multi-angle equations like this, where we ended up solving it and then having to divide or multiply again to solve for the x value, even though the angle might not be the same as the x value. However, these double angle formulas can come in handy when you're solving equations where you've got two different types of trig functions in the equation and you can't just solve it with one function. All right? And so here's the first example that we want to come to. We're asked to solve 2 cosine x plus sine of 2x equals to 0. And so, like I say on this one, because of this other cosine term here, we can't just go in and solve this like we normally would a multi-angle equation, because of the fact that you have the other term here with a different trig function in it. So what will help us here on this, and you'll see why here in just a moment, is to take this double angle formula and change it from this to this. All right, so let's see what happens. So now, once I substitute that in, I'll have 2 cosine x, and sine of 2x becomes 2 sine of x cosine x. So it'll be plus 2, all right, sine of x cosine x, and it's equal to 0. All right. So the reason why it helps me to break it up like this is because now I've got two expressions that I can factor a 2 cosine x out of. So I can factor a 2 cosine x out of this thing now. And when I do divide it out, that becomes 1. And then that's plus the 2 and the cosine cancel, and then so that's 1 plus sine of x equals to 0. Alright, so the fact that I was able to factor that expression out of there now can lead me to be able to write two separate equations to where I can solve each one and come up with all the answers. Alright, to whereas if I just tried to tackle this right here, I couldn't solve it like we typically solve the multi-angle equations, because like I said earlier, because of this cosine term. Okay, but when I use the double angle formula here to turn it into this, it develops into something that's factorable, and then that's how I can come up with my solutions. And so here we're ready to write two equations. 2 cosine x equals 0, that's 1, and 1 plus the sine of x equals 0, that's the other. And so here, divide by 2, we've got cosine of x equals to 0, and here move the 1 over, and we've got sine of x is equal to -1. Alright, so remember at this point, taking into account the range of sine and cosine, we're fine because it's from -1 to +1, including the in value, so we're good there as far as the range is concerned, so we can keep going. Alright, so from here, it looks like that in the first equation, I'm looking for angles whose cosine is 0. All right, angles whose cosine would give me 0. So that's what we're trying to see if we can't figure out here. So when we go in and we look, remember cosine is the x value, and so there's a 0 here at pi over 2. So we'll write that one in. All right, 0 at pi over 2. And let's see, where else are we looking at here? 3 pi over 2, right? And there's another one there, so that'll be at 3 pi over 2. Alright, so there's one. And let's see. And also remember the period for cosine is all the way around the circle, so that's why we're looking all the way around for our angles. We got 2 of them there. And for the other one now, for the sine of x to be equal to -1, we need to find out if there are any at that point that will allow me to come up with the correct answer there. And so when I look at this one, then what am I looking at here? All right, so sine of x is equal to -1. So I'm looking for angles whose sine is -1, right? And so the sine is the y-coordinate. So I'm looking for y-coordinates of -1. And I see only one, and it's at 3 pi over 2, all right? Which we already have as a solution, so we don't need to write it again, okay? And so those are my two, so I'll go ahead and explicitly write that out so we know that that's from the second one, 3 pi over 2. But then when I go to write out the full solution, we know that that one was already listed. And so that's going to be my interval solution from 0 to 2 pi. And of course, want to write out the general solution for this. Pi over 2 plus, and remember, since the period for sine and cosine are both going to be pi over 2, or excuse me, 2 pi, it's going to be 2 in pi, and then 3 pi over 2 plus 2 in pi. All right, that's the general solution. All right, so there we go. All right, so that's an example of how we can use a double angle formula in order to come up with one of the answers. We've got another one here. We want to solve cosine 2x minus cosine x equals to 0. All right? Now, so on one like this, since these angles are different, they're not like terms, I can't put them together. However, what I can do is I can use this double angle formula to make a substitution. Now, cosine of 2x is equal to 3 different things. So I need to take a look at the equation, see what I've got, and decide which one of these 3 is going to help me the most. And so how do I decide that? So looking here at the other term, it's also cosine. And so if I can actually get it to substitute into something that's all cosine, that would be helpful in trying to get it to a position to where it could factor, or maybe something could cancel out. So really, I don't want to use the one that brings sine into it, because now I'm all cosines. I want to keep it that way. And so I'm not going to use the first one or the third one, but I'm going to use the second one. So I'm going to substitute this to this. So when I write that in, it's going to be 2 cosine, just following the formula, squared. All right, 2 cosine squared of x minus 1. Then the minus cosine is still there. It's not going anywhere. Cosine x. And we're going to have that set equal to 0. All right, so that's my first substitution. I've kept it all at cosine, which is what I want. And notice squared first power, 0 power of the function, which means that it should be able to factor nicely. What I should probably do is write it in descending order of the variable. 2 cosine squared x minus cosine x minus 1 equals 0. That's typically the form we want it in when we start factoring it. It can go into a product of 2 binomials. And so to get this, we can go 2 cosine x and cosine x. So I'll go 2 cosine x here, cosine x here. So that'll give me the 2 cosine x squared. I've got a negative here, so I will have a plus and a minus, but I need to make sure that positive times a negative gives me a negative, so that's the only way to get it. But I need to know whether my negative should go here or here, because it does make a difference since these two are not the same. So look at the middle term, it's a negative, and so what that means is on the combination, when you combine together to get that middle term, you want it to be negative. So you want these two to multiply together to be a negative, so that the 2x is bigger, the 2 cosine is bigger than the cosine. And of course, how do I get 1? It'd be 1 times 1. So just double check, make sure the middle term checks out. cosine minus 2 cosine is negative cosine x. So we're good. So we got it factored. Zero product rule now. We'll go 2 cosine x plus 1 equals 0. That's one equation. Or we can go cosine x minus 1 equals 0. That's another equation. We can solve each one of these now. And so once we do, we can go, this would be cosine x, right, equals to negative 1/2. When I move the 1 over, it'll change the negative and divide by 2. So there's one equation. And the other one, when I move this over, would be cosine of x is equal to 1. Both within the range of cosine, which is from negative 1 to positive 1, including 1, so we're good there. And so let's see if we can come up with solutions. So the first one, x equals, all right, so I need to find angles whose cosine is negative 1/2. Negative 1/2 for cosine, so I need negative 1/2 for the x coordinate. Negative 1/2 for the x coordinate, it would occur there at 2 pi over 3. That'll be one answer. 2 pi over 3. All right. Is there another one? Still looking for negative 1s. And of course, right there at 4 pi over 3 is the other one. 4 pi over 3. Okay. And those are the only two. So now I can slide over to the other equation, which is going to be cosine x equals to negative 1. So I'm looking for an angle whose cosine is 1. I think it said negative 1 is supposed to be 1. And so let's see if we can find a place where the cosine is 1. That's the x coordinate being 1, which occurs only at one place, and that's at 0. And so we can get x equals 0 also. So now I'm actually ready to write my full solutions. We'll go with the interval solution first, which is 0. 2 pi over 3 and 4 pi over 3, and that's the interval solution from 0 to 2 pi. Okay. Now we can write out our general solution, which for 0 would be 2 n pi, sorry. 2 n pi. 2 pi over 3 plus 2 n pi. And 4 pi over 3 plus 2 n pi. And remember, that's to account for the multiples of 2 pi. That would give us another solution because of the periodic nature of the function. And that's the general solution. So there you go. Okay, let's shift gears now and take a look at a different set of formulas. So these are the power-reducing formulas to take it from sine, cosine, or tangent squared to be written as cosine to the first power of a double angle formula. Okay, so typically we don't always incorporate these in solving equations, although they can be. Let's see. Typically, what they will ask you to do is something like this. Rewrite sine to the fourth x as a sum of first powers of the cosines of multiple angles. So really, it's a kind of technique where you can use to rewrite a trig function that's of a higher power back to the first power. And that can be useful in different applications, like you see here, once you get to calculus and that sort of thing as well. All right, so let's see, how can we do it? So I want to take this thing, sine to the fourth of x, and I want to see if I can start trying to reduce this power down. Okay, so I've got sine. So sine squared is equal to 1 minus cosine of 2u over 2. All right, so what I can do is I can rewrite this sine to the fourth of x can be written as sine squared x to the second power. All right? So that's the first thing that we need to notice, is it can be written in this form. Okay? Now, the reason why that helps me is because I can now at this point rewrite the inside of this using this formula. So what I'm going to have now at this point is I'm going to take sine squared x about and put this in its place, 1 minus cosine of 2x over 2, close it, square it. Okay? Alright, so now at this point I can actually square this thing out. And so this would be 1 minus cosine of 2x times 1 minus cosine of 2x. So I'll multiply it out using the distributive property as I normally would. 1 times 1 is 1. Alright, let me see. How do I want to write all this? So 1 times negative cosine of 2x is negative cosine of 2x, but then I do it again and have another negative cosine of 2x, so that would be altogether minus 2 cosines of 2x when all is said and done and everything's put together in the middle. And then on the end, it's cosine 2x times cosine 2x, which is cosine squared of 2x. Okay, so at this point, this is what we've got, and all of this is still a fraction, actually. And it's all over 4, 2 times 2. Because remember, everything was squared here. Okay, so here's what we've got now at this point. And so now, I can take this thing and just see if we can't continue to start simplifying it down. As a matter of fact, you guys are going to like this. Now I can use the power reducing formula again for this cosine squared. And I'm going to write it as this. So I'm going to have 1 minus 2 cosine squared x plus, now what does cosine squared turn into? Cosine squared of 2x now will turn into 1 plus the cosine. Now be careful here. 2x will turn into 4x. So that now becomes 1 plus the cosine of 4x. And then all of this now is over 2. So what I did is I took this part and put it into the power reducing formula here. So if this is 2x, then u becomes 2u. So 2x becomes 4x. All right, and then over 2. Now all of this is still over 4. So I've got a fraction within a fraction, which is always nice to have. Okay, so let's see what else we got. So at least now we've accomplished the goal as writing it as a first power of cosines, right? We've written it as a first power of cosines like the directions have told us to. But now what we need to do is see if we can't simplify this sum and put it in a better form. Okay, so the first thing that we should probably do here is, let's see, I can take this and write it as two separate fractions, you could say. So this would be 1 minus 2 cosine of 2x, and then plus, we can go ahead and make that 1/2 plus 1/2 cosine 4x. All right, and then all this is still over 4. Okay, so at least it gets us away from that fraction over the fraction look, right? So now we just kind of got fractions in front of this, which is fine. Which you'll see how this simplifies here in just a moment. Keep it going here now. Let me run out of room here. That's not good. Let's see. Okay, so from here now at this point, what can we do? Let's see. The best thing probably to do here is add the 1/2 and the 1, right? The like terms there, and get 3 over 2. So it'd be 3 over 2 minus, is that all we could do at this point? I would say yes. Minus 2 cosine 2x plus, this will still remain as a 1/2 cosine 4x, okay, and all still over 4. All right. See what else we can do here. Okay, at this point, I think we are ready to divide 4 into all of this. All right. And so when I divide it by 4, that would be the same thing as multiplying by the reciprocal, right? So I'll be multiplying 4 into the denominator of all of these terms, and once that happens, 4 times 2 is 8. So that'd be 3 over 8 minus 2 over 4 is 1/2, so that's 1/2 cosine 2x plus what, 1 over 8? 1 over 8 cosine of 4x. Alright, so that's what we have now here. And I would say probably just one more thing to clean it up a little bit would be to pull a 1/8 out of each one of these. And here's what would be when we say that. When I pull a factor of 1/8 out, okay, that's really the same thing as multiplying everything times 8. Okay, just to get rid of the fractions here and just make one factored fraction on the outside. So I'm going to pull a 1/8 out of here, which means I'm going to really multiply everything here times 8, right? So if I'm pulling out a 1/8, then I'm multiplying everything times 8, because typically you're dividing by whatever you've got to pull out there, right? So here this will be if I multiply by 8 here, so I'm pulling a 1/8 out of here, which means I'm dividing by 1/8, which is times 8 is what I'm getting at. That'll cancel and leave me with 3 minus the 8 here divided by 2 will make 4, so that's 4 cosine 2x plus the 8 cancels there and just leaves me with plus cosine 4x. Alright. And that's probably the simplest form that we will leave our answer in. Okay, so what did we do? Okay, we took this thing and, as the direction says, rewrite it as a sum of first powers of cosines of multiple angles. And we use these formulas in order to do it. So we had to get this thing down from fourth power to first powers of cosines. And then that's what it would be equal to. All right? So there you go.